is an associate professor. Dr. Hoque is an associate professor of computer science at University of Rochester, where he co-leads the Rochester Humans Computer Interaction Group. And he has also served as the interim director for the Georgian Institute of Data Science from 2018 to 2019. He has earned his PhD from MIT in 2013, and his dissertation was highlighted in the MIT Museum, where he focused on the development of an intelligent agent to improve human ability as one of the MIT's most unconventional inventions. And building on this work and patent, Microsoft released Speaker Coach, which several of you might be familiar with, which is available in PowerPoint. He is best known for introducing and extensively validating the idea of using AI to train and enhance elements of basic human ability. He and his students have been recognized by the NSF Career Award, MIT TR35 Young Investigator Award by the US Army Research Office. In 2017, Science News has named him as one of the top 10 scientists to watch. And in 2020, the National Academy of Medicine recognized him as one of the emerging leaders in health and medicine. He's also an inaugural member of the ACM's Future of Computing Academy. So it's an honor to have him here today to share some of his research on using AI to improve human ability. Give him a warm welcome. The floor is yours, Ehsan.
Thank you. Glad to be here today. Even though I would have loved to be in Texas right now, enjoying the 70 degrees weather. And everybody else, looks like there are 30 plus individuals. Thank you for being here. I'm going to ask a lot of questions throughout the talk, so feel free to use the chat or use the microphone to engage. I think we'll have a lot of fun if all of us engage. So I will start the talk by playing a 1-minute clip. Just watch.
Where measles came up.
Wait. When did I mention measles?
I don't know. It was on you.
Wait, what was on me? What are you talking about? Right? Is Raymond even hearing what I'm saying? I never had the measles.
Was on you.
We never did a measles and vaccine episode. Is this a joke?
I know.
I don't even know what you're talking about.
It was on you. It was on you.
I've never had, Raymond, I've never had measles. What are you talking about? This is stupid.
It was an episode of a show, Laura.
What's it called?
You.
What is he talking about?
It's called You.
I've never done a show on measles. I just completely give up. We got to get
It's a show
I give up.
called You on Netflix.
There's a show called Laura Ingham on Netflix. What are you
Never
talking
mind.
about?
I'm moving on to it.
All right, so the question to you, what happened in the conversation? Why was there a miscommunication? Any guesses?
Because the guy that is the host, he was talking about a show which is named You, but the female, she's thinking that he is talking about him, talking about her having measles on her.
Right, so there's a lack of clarity. Thank you for that feedback. I see some information on the chat as well. Havi talked about lack of information. Fatima said the name of the show is You. So You is ambiguous, like what's you? And then he was also using the gesture, like you, pointing at her and then saying you. And that got confusing. Yeah, Jeff is also correct. So he was pointing his hand. Of course, you should be using gestures, but when you use it in an inappropriate way, everything changes. So as a researcher, I'm obsessed about understanding this unwritten cues about human communication. And computer science is a nice way to be able to study it. In fact, there's a quote by Edward.
Where measles.
Like we respond to gestures in accordance with a code that's written nowhere, known by none, but we all understand it. This was an anthropologist done quote from 1927. And my intellectual curiosity as a computer scientist stems from this quote. First of all, I like studying human behavior It's fascinating, and computer science provides an objective way to study it. So in my talk today, what I'm going to do is I'm going to structure my talk in two different segments. For the next 10 to 15 minutes, I'm going to go on a rapid round to give you wide coverage of some of the things that could be done on this space, just to give you some perspective. And for the remaining time, I'll go deep into 3 different projects on healthcare, just to provide an idea as to how you can go from problem to solution to possible deployment. So that's the agenda. So let me take you through a rapid round for the next few minutes, just to tell you about what's possible and what's been done. So in the past, people have studied human behavior. I mean, that's what the field of psychology is all about. And in those cases, they would bring people into a lab and have them do a task, and you'd have cameras like we have here and study the data. The obvious limitation is that you can't really study hundreds of thousands of people that way, just simply not scalable. Now, one advantage of virtual communication, like we have been doing during the pandemic, is that we can study it really well. And many attributes of human behavior you carry on to virtual environment as well, while certain things are very unique. And that presents a very unique way to study human behavior in a scale that wasn't done before. For example, we can now study the human dynamics of a conversation that's been studied by many people. In our case, we studied how people are responding to each other, the synchronization, and then from there, we could predict the outcome of a negotiation. Like in a negotiation, it's like a dance. 2 people are negotiating. Just by studying the behavior in a scale, we could predict the outcome. We built a framework where it can automatically get people from online. Let's say we want to do all this online, right? So we don't want to bring people in the lab. So how can they do this in a fully automated way? So this is a framework called Adder, where we want people to perform a task online using webcam. So this is the crowdsourced workers. The framework can automatically check for the audio video data. And then we can filter the participants to make sure we only bring in people who have at least decent bandwidth and audio and video quality. And then we can randomly pair them up. And we can give them a task, and researcher can decide what that task might be. And the participants perform the task, and the audio video gets automatically stored. So it's a fully automated framework. You can just deploy this online, and without doing much work, you can get hundreds and thousands of data of people doing some task of your preference. So in our case, we were interested in understanding credibility. Like, how do you know when somebody's trustworthy? So by using this kind of framework, we're able to collect data in a scale that never done before and study human behavior. I'm not going to have time to go through the entire scope of credibility, but these are the papers we have published, and there's a link from my page that has more details about this. But just by building this kind of framework, we could study facial expression during credibility and the role of facial expressions, language, and as well as eye contact.
One of us.
In fact, just to promote the idea of multimodal behavior in the context of credibility, let me play a quiz. So I'm going to play a video, and you have to guess at the end. So please pay attention.
Is not telling the truth.
Can you tell which one of us
is trying to deceive you?
I'm fluent in 3 languages.
I grew up in Shanghai.
I grew up with 5 different pets.
I have never traveled outside of the United States.
I have never broken a bone.
My favorite author is Ray Bradbury.
So,
did you guess which one of us?
Which one of us? Which one of us is?
Any guess as to who is a liar among the 6 and why?
I would guess it's a middle on the bottom of the guy.
This person?
Yeah.
Why?
As I talk, he uses one of his right eyes and, see the other angles, not face-to-face angle. He's trying to manipulate the information.
Okay, sure. Thank you for the response. Any other guesses?
I think all of them are lying.
Okay, one more vote for him. Anybody would differ?
The top left guy, he took time to actually tell who was his favorite author. He took time to realize and he might be like.
Right. Okay. And he was doing something shifty with his eyes as well.
Yeah.
Okay. Okay. Thank you for the response. Anybody else? All right. Well, this was acted, so it's pretty obvious who was the author, and Brian got it.
One of us.
So it was him. So Brian was correct, and this was acted, but just to get you an idea that how those behaviors come in the way of interfering with the judgment. And if you look at the interrogation literature, even an expert interrogator, it's 50 to 55% accurate in predicting whether somebody is innocent or telling the lies. So if you can use some kind of technology just to be able to amplify the human's ability to do this better than 50%, which is a coin toss, that would be a contribution. We talked about people interacting online. How about collaboration, like having conversation in Zoom? So this was work done before the pandemic, where you looked at how people are collaborating online and what could you do to be able to improve the collaboration, make them more productive using AI without telling them what to do. So let me play a clip of 4 people trying to solve a problem.
Number 3, I got the food.
I said the map.
The constellation, the stellar one?
Yeah.
Yeah, I actually had that one just below that one, so.
Uh-huh.
What about you guys?
I had the 2 caliber pistols, but in retrospect, I don't think you probably encountered too many
Why would you need a gun?
There might be those moon bears,
That's true.
It's not to be vicious.
You realize the only thing you'll be using it on is either blowing up your own allies' oxygen tank or shooting them, right?
That's true.
Or you could.
All right. Anything you can talk about this encounter? Anything to share? Any comments, observation?
One of the guys didn't talk at all.
Okay, you're right. So this person didn't speak at all. So even if you don't want to get into the dynamics of the conversation, it's pretty obvious that participation was low from certain participants. So we built a framework. We can automatically take the video and audio and analyze it for many different attributes, including participation. And in this case, what happens is once you're done with this one round of conversation, you get feedback from the system where it's more of like a coach that walks you through of what just happened in the conversations. Kind of like this: hey, I'm Roboto, I'm your assistant. I'm going to walk you through what just happened. So every person goes through this kind of interaction, and it walks them through of participation, valence, emotion, conversation, many of these things. So in this case, you saw the last one. So this is one of the graphs just on participation. And just by looking at it, you notice that one person dominated the entire conversation, even though it was supposed to be a equitable brainstorming session. And this person didn't speak much. So we use AI as an arbitrary mediator. We don't tell this person that, hey, you got to speak up or you got to tone down. We just show the data and talk about the importance of equal participation. And we notice that by giving this kind of feedback, by adding transparency into the conversation, we can make the conversation a bit more equitable without telling somebody that, hey, you are being difficult or you need to speak up. We also played around with real-time feedback. So imagine as I'm giving a talk right now, and I'm speaking really, really fast and not slowing down, what if I could get a real-time feedback and saying that take longer pauses, overall, you're doing okay. So we played around with those as well. And the challenge in here is that how do I give the feedback without really interfering with the flow of the conversation and still give you the information? So just to give you a rapid answer, with nonverbal behavior, you can study individual behavior, you can study crowd, you can study two people interacting, you can study group, like the one I talked about in the previous slides. You can also study how an individual interacts with a network of people. That's relatively underexplored. And in our case, we looked at, can an individual be more creative from a network of people around them, right? So if you use social media, many of you go to Twitter and perhaps you follow some thought leader in the field because you want to get some ideas from them, right? So what we find is that if you follow somebody like, let's say, Bill Gates, you're more likely to be creative because they have good ideas. Just by following them, you have access to better ideas. But here's the catch, is everybody else in your class or university is following the same individual, then everybody's become equally creative, but there is redundancy in the ideas that you're generating, which is the opposite of being creative. So what we find is that there is a way to intervene so that if you are following someone else's idea, perhaps I can follow somebody else. So there is a way to be able to mediate so that everybody's creative output is maximized, as well as the collective creative output is maximized. So there's a lot to do there by forming the right set of groups to improve some of the creative skills as well as other soft skills. Like this was in the context of creativity, but it could be applied for other soft skills as well. So we talked about two people interacting, multiple people interacting, but how about one person interacting with the computer? It's not as weird as we used to think. So here, this was an application where, imagine, let's say you have an internship interview and you have a very strong resume. So you got the interview, but then in the resume, they want to know more about who you are. So you want to get some practice. So this avatar who can see you, listen to you, and respond to you in real time, and can play the role of a conversation partner and can give you feedback on your interpersonal skills. So I'm going to play a quick video of a person going through the intervention.
Please tell me about yourself.
So, I am a junior at MIT and I study biology. I am involved in a variety of activities. So, the biggest part of my week is crew. I'm a varsity coxswain on the heavyweight men's team. And let's see, so I'm also involved in synthetic biology research. I work in the Weiss lab here at MIT.
And then he came back and did one round of interaction with the AI-driven character.
Start with providing some details about your professional background.
So my name is Charles, and I'm an undergrad student at MIT studying biology. I am currently a junior, and so will be working the year after I graduate, which is next year.
Okay, and after 1 week, he's interacting with a counselor.
Please tell me about your background.
So I am a junior studying biology at MIT, and I am part of the crew team. I'm a coxswain on the heavyweight men's team. So what I do is I coordinate practices on the water, and also I coordinate races. So I call tactical moves. I'm the only person who's actually facing forward in the boat.
So did anything change for this individual before and after the intervention? Anybody? No change?
Confidence.
Confidence. How do you measure the confidence?
Eye contact, body language.
Sure, yeah, that's a good insight. So he was making a lot more eye contact. He was using body language. So he was perceived to be more confident. And that's the thing, by nudging people the right way, perhaps there is a way for them to project their best behavior. So in this case, they practice and they get post feedback. We did one other experiment where imagine this is a person and he wants to improve some of his soft skills, like how to make small talk conversation. And this is an avatar, and it provides real-time feedback. So in real time, it's analyzing the audio and video. And based on that, it's making a prediction as to whether he should be smiling more or whatever. So you see there are 4 icons. There are 4 green icons. Any guess what that first icon stands for? What it could stand for?
Eye contact.
Good. Eye contact. How about this one? The next one.
Facial expressions.
Okay, smile. Yep. How about the next one?
Active listening.
Yeah, active listening or volume modulation. And the last one is body language. So good job. So I'll play the video and you see how AI gives him feedback on those skills. It will turn red and what he does to recover from it.
What was your favorite class so far?
Probably microeconomics.
Did you find it hard?
A little bit. I think it was more interesting than it was hard.
I like artificial intelligence. That was my favorite by far. Though obviously I am a little bit biased on the subject. I really think the material is great and the prof is even better.
So this was proof of concept for first-year college students, just to be able to help them improve some of the soft skills if they wanted to. I think the best help that you can get is talk to another human, go out, be social. But let's say if you don't want to do that, if you want to practice at the privacy of your own, with standardized, repeatable stimuli, we have something to help. In fact, we then repurpose the same system to help individuals with autism, right? So autism is a condition that could limit some of your social ability. Here we ran a similar one. It's a dialogue system that allows for conversation. So in autism, many individuals don't realize that they are monologuing without realizing they're monologuing. Sometimes they don't ask reciprocal question. Like if you ask me, what's my name? I should ask, what's yours? It's courtesy. So often they need some nudge to understand how to do those basic things. So imagine a stimuli where they can practice whenever they want, whatever they want, at the privacy of their own and get feedback. And one sweet spot of using technology to give feedback is that you can't really get mad at it, right? So it's objective feedback and you are less likely to have a meltdown versus when you imagine working with a real human who's constantly giving you feedback. So I'm going to play a video of an individual trying the system.
Yeah. What do you like most about Rochester?
Well, I kind of like a lot of things about Rochester. There are so many, I can't pick one.
That's right. And what do you not like about it?
Well, I like everything about it. I like a lot about it. I can't tell what I don't like about it.
That would bother me too.
So this person has difficulty with posture. He will end up slouching a lot. But imagine as he's getting feedback, he's making an effort to correct his posture. So it's not going to be fixed overnight. But as you continue to practice, it could perhaps become a muscle memory and you could learn to internalize this. We also use the same system and repurpose this to help individuals with elderly who, due to isolation, don't have human contact. And perhaps they want to try speaking with an agent just to be able to see whether they are able to retain their skills or they may need some feedback as well. So that was another application we looked at. For the interest of time, I'm going to move on because I have some demos that I want to show you. So when there is a press release on my automated conversation coach, we got so many emails that we built an online version of this. So if you go to rockspeak.com, you should be able to see it. It's available live today, so I can give you a live demo. So it's right here. I can practice now. You can see me here. The other camera turns on. So, all right, so I'm going to practice Rock Speak here. it's risky to do a live demo during a talk, but hopefully this will work and I get some data back. I haven't tried this in a while, but things should just work fine. So in a minute or two, all the data should be processed and I should get some feedback on my public speaking skills. So when I stop recording, it's now being sent to the cloud and it's now analyzed. So it will take a minute or two for it to analyze my facial expression, what I said, and how I said it. And one thing is, this work resulted in a patent. Now Microsoft sublicensed the patent. So every single time when you present in PowerPoint, there is a feature called Rehearse with Coach. So right now it's doing, and I am now rehearsing, and it's using the pattern that we have created. So it's really satisfying to see, I don't know, to be able, oh, so now it's giving me feedback that, hey, try not to use too many fillers like So the feature is available, and I'm so glad to see that the work that we have done in early 2010 resulted in a patent, and now millions of people could use this through PowerPoint and be benefited. So when I hit this, I don't know whether you have tried this, but it gives you overall feedback as well. Just the one like the one we have created, like pace, my pitch variation, I started well. My average pace over time, I started speaking faster here, and fillers, I said fillers once and all that. And if you go back to the one that under processed, that should be coming up soon. Yeah. So this one we built in 2014. See if I play here. So, all right, so I'm going to practice a rock. So the purple line corresponds to my smile. So I smiled a lot. And this yellow line, or orange or yellow, correspond to my body language. So I didn't have much movement here. I can get some feedback on my volume modulation as well. I can see word cloud, and I can see some of the filler words I might have said. And we made it in 2014, made it public for anybody to use it. And then since then, thousands of people have tried it. So there's a question, how do you determine the appropriate levels for the metrics used here? And how do you decide the best facial expression, body language, volume? That's a great question. So in this case, we are only recognizing smile here. So you're just smiling. We are not telling you that, hey, you need to smile more or less, because that's a very, very subjective process, right? AI is not there yet to be able to do that. And even if it does, we don't want it to be prescriptive. We don't want to tell people what to do. We want you to use the style that you have to be the best you could. So one thing we tried was, if you just click here, it creates a link, and I can share the link with people that I trust, and people can watch the video. All right, so I'm going to practice rocks. So you can say, nice job smiling here. Speak here. It's risky to do a live demo during and say you're moving too much. A talk, but hopefully this, so I can give myself, since I'm rating myself, I'm going to give full star and then hit submit. And then the rating should appear here pretty soon. So the main idea is that if you like, you can get some objective data. And if you want, you can also share this data with people that you trust, and then you can get a lot of feedback from people. For example, here, this is a case recorded one, and you get a lot of feedback, and we can automatically rank it based on helpfulness. And the feedback also appears here. So if I take my mouse over here, this is where I'm getting a bit more justification. What's good? How am I resonating with the audience? So this was purposefully designed to be a hybrid approach of AI and human coming together. Instead of being prescriptive. I think prescription is not good for AI to provide, especially in the context of public speaking. And the question is, does the objective feed go back? Yes, it's always learning. So all the stuff we're getting, it's constantly going. In fact, the comments are also being fed into the learning. So that's one good thing, is having a lot of this data. It's going back into the system, and you're always thinking about, okay, what are the new things we can add some objective metric to? Good question. All right, so, and this is the press release last year, I think, when Microsoft introduced this patent to provide feedback on public speaking right now. So it's available for all of you. All right, so now that I have 15 more minutes left, I'm gonna get to the main part of the talk. And if there's time, hopefully I will talk about the first two things. Neurological care available anytime, anywhere. So every work that we do has a story, right? So my mother has Parkinson's disease. So I have very fond memories of giving her doses of medication to control her tremor. So fast forward into 2015, I saw a neurologist at the University of Rochester Medical Center. I made an appointment. The first thing he did was took a big book and just threw it on the table, saying that, hey, all the stuff that we do with movement disorders, it's pen and paper based. There is no automation, there is no AI. Any automation that you could bring would be contribution in healthcare. In fact, one slide that he showed was very, very revealing to me. So for Parkinson, all the metric under this slide, it's what being measured right now, for which people have to come to a clinic. But there are other metrics as well that's very relevant and important, but there's no way to measure it. So any passive sensing that you can introduce to get more information about people in their own environment would be a game changer for healthcare. And in case you don't know about Parkinson's disease, it's the fastest growing neurological disability in the world. It's growing faster than Alzheimer's. It introduces involuntary tremor of your body. There are 10 million people with PD, and it's going to double by 2040. It's an incurable disease, but it's very treatable if early diagnosis is possible. The best possible treatment is 50-year-old and has many side effects. Access is a problem. For example, in India, get this number, 1 neurologist versus 1 million people, right? In 23 African countries, 1 neurologist versus 6 million people. So this is a big problem, and we need to find a way to scale some of this treatment. In USA, 40% of individuals with Parkinson do not receive care here because we simply don't have the resources for it. So our vision is simple. So imagine anybody from any part of the world can go to a website through the computer browser, turn on their webcam, and perform a set of neurological tests that you would do in a clinic, but now from your home. And using AI, we can do two things. Number one, we can screen for Parkinson, give you a referral that, hey, you might be showing early signs of Parkinson, go see a neurologist. And application two, if you do have Parkinson, now we can measure the severity of the tremor from home so that you don't have to go to a clinic. Because for Parkinson, we want to get a sense of how well you're responding to the medication. When you get that, then they can fine-tune the medication. And as a result, the medication can last longer. Right now, doctor sees a patient in a few months. And there's just no way to fine-tune the medication if you don't see the person every single day. So if this technology could be available to people using phone or computer, they could do this whenever they want, share this data with neurologists, and they can fine-tune the medication, and the medication can last much longer for a disease that has no cure. So this is the big picture. You have a site, you go, perform a set of tasks. We built a framework. It's available at parktest.net, using which we have been collecting data from all over the world. People go to the website, turn on their webcam, and perform those tests. These are some of the examples of data that we have collected. And you can tell these are very naturalistic data. These are individuals with Parkinson from different socioeconomic background as well as ethnicity doing this from their computer. And these are different tasks that you usually do in a clinic, but now you're doing this from home. The tasks include facial expressions as well. So these are all part of the standard test you do in a clinic. And if you work on computer vision, you can immediately thinking, you know what, I might be able to quantify some of these movements.
20, 19,
This is
18,
a cognitive test where you have to
17.
count down.
1, 2.
So we got a lot of data, and we have the largest data ever collected on Parkinson's using the framework from all over the world. The idea is to perform the test and get some feedback. Now, if you work on computer vision, you can immediately find out that data is very challenging, right? There are different lighting conditions, hands moving out of the camera a lot, so you can't really count them. People often don't follow instructions. We ask them to do things 8, 10 times. They either do less or more. The cameras are everywhere, so you get different angles. So how do you deal with this, right? In fact, in machine learning, you know that this is what it looks like for training. If you want to build a classifier for cats, but then when you go in the real world, this is what you see. In fact, there is a criticism of many of the algorithms is that you cannot really assume all the possible deployment settings when you're building an algorithm. And as a result, there's a disconnect between what we have in terms of algorithm and what's been deployed in the health setting, because we just don't know the unpredictable settings in the real world. And in our case, we said, you know, what if we do know that? Because we were collecting data from people's own environment all over the world. Perhaps the data contains the real world variability that we can potentially solve. Now, if you work on computer vision, you know that this is the state-of-the-art computer vision tool that can recognize your hand postures and everything fairly, really well. So we looked at this and we felt very encouraged. Perhaps you can take this framework and apply it on the data that we have been collecting. So let's try it. So this is a person who don't have Parkinson. PD means Parkinson disease. So it does a fairly good job with a good background, tracking the hand and all that. So we felt encouraged. Then we tried somebody who does have Parkinson. This is a naturalistic data, and you see data is not working the way you want it to be. One hand, it didn't work. Let me show you one other video. So here it's actually tracking the other person on the side and not even tracking this hand. So this is the state of the art. And you know, this happens because when you build this algorithm, they probably worked with healthy patient and didn't take individuals with Parkinson's disease and training data. As a result, the best algorithm that we have don't work for this population. So what we did was, you know what, we started with a problem. So this is the problem. This is the data we have. We need to solve it. And then through that, backtracking it and build the technology accordingly. So for the next few slides, I'll just walk you through some of the algorithms that we have built. So this is the motor symptom where they are doing motor task. So let me just quickly walk you through of what's happening. So we have the entire video where they click on open webcam, and then they perform the task and click on, okay, close webcam. So we can automatically find this segment of interest by using an algorithm. Then we can perform a spatial segmentation where you can blow out the background. And then we can perform an algorithm called motion magnification. The simple idea is that I have pixels, and I'm just going to multiply each pixel of an image by, let's say, 10, 20, or maybe 500. And when you do this, you start to seeing patterns that are often invisible. That's just a simple term called motion magnification. And when you start doing this, now we can do a fairly good job in recognizing between PD versus non-PD with 90% accuracy. Anybody knows who this is? This is Michael J. Fox, who had Parkinson's disease when he was only 28. And this was an interview when he wasn't even talking, and look at the movement, involuntary movement of the hand as well as the head. And that gave us some inspiration. Perhaps maybe the way you're moving your head has some information about whether you have Parkinson's or not. So I'm going to quickly, so here, simple idea, we have this different data we're getting from the tracker that correspond to my movement. We apply fast Fourier transform and do some calculation on them, get the amplitude, and then we get to 6 different channels rather. Tx, Ty, Tz, and then Rx, Ry, and Rz. Any guess as to which channel has most information about whether you have Parkinson's or not? Anybody want to entertain me with a guess?
Frequency, movement.
Sorry, Tz. Okay, I have one vote for Tz. All right. It's actually Tx that has more information, but it's nice to be able to validate that. So that's with the head pose. There is one other thing we did on expression. So people who are doing expression, and this graph is interesting because if you look at it here, x-axis is my time, and y-axis correspond to a measurement called AU12, action unit 12, which is my lip corner pull. So if I start smiling, that number will become large. When I become neutral, that goes to 0. So here, something is happening. So we asked them to smile 3 times. So this is with people with Parkinson. And this graph is for people without Parkinson. And this is the plot of AU12, how they're smiling. Can anybody tell me, is there some difference on what does the difference mean? Any guesses?
Not a guess, but it's surprising that PD is the one on top. Because it looks more consistent almost.
Yeah, it's very non-intuitive, right? So, and when you start talking to, Ernest talked about faster smile, yeah. When you start talking to neurologist friends, then they were able to justify this. Like in this case, what's going on in that they have less modularity, less flexibility, the way they're smiling here. So there is this consistent pattern versus when you don't have Parkinson, you have a lot more flexibility, spontaneity, and which is being captured in this graph. It's invisible to the human eye, but when you start plotting them using AI, you start to see those patterns. And one good thing about this is, imagine as you're taking selfies, what happens? When you get your phone to take a selfie, the phone is clever. It takes a video clip of 3 to 4 seconds. And in most cases, when you're taking a selfie, you probably smile. So you may already have a lot of clips of you smiling. And if you give permission, we could go and analyze those clips and give people early referral in case they're showing signs of Parkinson. In fact, if you have a phone that requires your face to unlock, that could be another way to be able to passively monitor your expression and give you a referral in case you're showing signs of Parkinson's disease. So those are the passive sensing that we may see a lot more in the future integrated with our technology. There's one other task. This is a speech task where this person is saying a sentence.
The quick brown fox jumps over the lazy dog.
So I'm not going to play this, but one thing is this is called a pangram. So this contains all the alphabets of the English language. And if you look at it, this sentence comes back again. And what we notice is that if you do have Parkinson, by the time you come here, people get tired. And it's kind of reflected the way they're pausing, the way they're breathing. And we can easily tease that out using AI, even though it's really difficult to hear on the audio.
The dog wakes up and follows the fox into the forest. But again, the quick brown fox jumps over the lazy dog.
So just by analyzing those characteristics, we could do a really good job in recognizing whether somebody has Parkinson versus not. And so imagine if you have Alexa or Google Home at home, if you're talking to them, if you give them permission, perhaps they could analyze the way you're speaking and give you early referral of whether you're showing early signs of Parkinson's or not. So these are all the algorithms, but let me just show you a live demo of how we can kind of put all the algorithm towards a system where I can perform those tests live and get a referral. So let me go to this here. So this is deployed. So if I click here, get started, ask me to log in. So I'm going to go through 5 tests and it's asking me exactly what I have to do. So I hit start. And here the video contains instructions.
For this task, make sure your face is still in the recording frame and recite the following sentences.
The quick brown fox jumps over the lazy dog. The dog wakes up and follows the fox into the forest, but again, the quick brown fox jumps over the lazy dog.
Okay, let me record myself. Quick brown fox jumps over the lazy dog. The dog wakes up and follows the fox into the forest. But again, the quick brown fox jumps over the lazy dog. I finished that. Go on to the next task.
For this task, you're going to take your index finger and your thumb on your left hand and tap them together as quickly and as big as possible. So for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10.
Okay, let me try that. Okay, I have 3 more tasks left.
For this task, you will make the biggest smile you can, followed by a neutral face. Repeat this 3 times. So for example.
Okay, let me try that task.
For this task, you will make the most disgusted face you can, followed by a neutral face. Repeat this 3 times. So for example.
Try that.
For this task, you will move your eyebrows up as high as you can and down as low as you can 3 times. So for example.
Try that one. That's the final one. Video's too short. Okay, let me try again. All right, it will take a minute or 2 to be able to do the analysis. It's going to run the facial analysis. Then we'll run the analysis on the finger tapping. And then we'll run the analysis on my speech and give me a probability of whether I have Parkinson's disease or not. And let's say if you, in addition, it can also give you access to resources. If I come here, so if I want to say, okay, let's say it tells me that maybe I'm more likely to have a disease, so I can click on Find Neurologist to see where I could go. If I want, I can also click on support groups. That tells me that support groups I could reach out to for more information. If I want to get advice, let's say I don't have Parkinson, but I want to have a good life, I want to follow instructions. These are some of the things we can give people access to. So it's still running the analysis. I should get it back in a minute or 2. Is there any question while it's processing it?
I guess a question about all this data. So who has access to this? Is it just the medical community or is it used for elsewhere?
Sorry, who has access to the data?
Yeah. Is it just the medical researchers or is it anyone, I guess?
Right. So this is now, this is being run with our institution review board. So where we are collecting data. So only our team, who's part of the research, has the data. And we control the data, and we have to delete the data after 7 years of completion of the study. So the referral came back. It says very unlikely that I have Parkinson, and it also gives probability based on individual modality. For example, based on speech, there's only 5.45% probability of Parkinson's disease. From face and from motor, it's fairly low as well. So what we are really after is that it's not a diagnosis, but more of like a screening tool for people who don't have access to care. And we want to be able to at least refer to the right places so that they could get the checkup and get an official diagnosis. So this is being funded by Moore Foundation, and our goal is to be able to get an FDA approval, hopefully by 2024. And FDA told us exactly the metrics we need to hit for it to be approved. So we have a goal to work towards. So this was Parkinson, but if you think about the body of disease for movement disorder, there are other things as well that share a lot of similarities, like ataxia, Huntington disease. So using computer vision and machine learning, as you can quantify many of this behavior, this will have a broader appeal across movement disorder. For example, this is with ataxia in collaboration with Methodist Hospital in Houston, where it's similar to Parkinson, but it's not Parkinson. As a result, they get misdiagnosis a lot. And we are using computer vision to quantify the severity of ataxia. And this image is about data from different sites, because often there is a problem with generalizability of the technique. So we are making sure to get data from different places, different settings, different people, and using the technique so that it works not only for one site, but for all the data for which we have collected data. All right, well, I know I'm supposed to end at 45, so I'm already behind. So I was gonna talk about end of life communication, but I'll end it here. And then, maybe I'll just play this short clip. It's a 30-second clip. So this is about a doctor practicing end of life communication with a virtual agent.
At this point, ME just want to spend time with family and prepare myself for the worst. What are my choices at this point?
It sounds like family is really important to you and having time with them. So I think we should focus on options that allow those two things. And those options might include chemo.
I see. My previous doctor mentioned something about chemotherapy, but he said to wait to see how things go after the radiation. Do you think I need chemotherapy?
It really depends on what your scans look like.
So this is an intervention to help doctors to have more empathy towards the patient, listen carefully, and be able to understand their preferences as they go through the end of life. So I think that's all I had. I just want to acknowledge my team for all the work they have done over the years. And on that note, I will open up the floor for questions. Thank you.
Thank you, Ehsan. That was a great talk. There are a few questions in the chat window that weren't answered. I think one from Fatima.
Okay, let me see if I can.
Fatima, do you want to ask the question?
Sure. Thank you for the great talk, Dr. Hoque. My question was, we as humans often pick up subtle cues in conversations that may be difficult for AI to pick up. Like, for example, we can sense if someone's being condescending or dominating in a conversation just from the tone. So I was thinking, can platforms like RockSpeak could help people be more empathetic and respectful speakers as well?
Yeah, in fact, I just graduated a PhD student where her topic was exactly this. And she was a female, and she often was subjected to microaggression in a conversation. Many people insert this condescending or microaggression without realizing they're doing this. And she was planning to study this. And she was studying conversation in Fox News as well as CNN when they bring in hosts and how they insert when they raise their volume. And how can you get that? And how can you also intervene effectively? So her name is Samiha Simrose. Maybe you can, if you look at Google, you will get to some of her work. I think that was exactly her PhD thesis.
Thank you.
There's another question from Sherry, I believe.
do you find the medical community, oh, thank you for your presentation, by the way, it's very exciting. Do you find the medical community seems open to embracing computers, helping them do their job? My experience was they were pretty territorial, thinking that a computer was going to diagnose or a computer was going to help them.
Right, so all the stuff we talked about, this is in collaboration with medical folks. So they're the one who told me that this is what they need help with. But I agree with you, there are traditional people who don't believe in technology, but there are other people as well who believe that technology is the way to go. For example, I talked about this is being done with Ray Dorsey from University of Rochester. Together, we have an NIH grant for which we built a new center where we have computer scientists from MIT, Johns Hopkins, as well as UFR, working closely with a neurologist. So there are thought leaders in the field who can identify the sweet spot. And if somebody's giving a pushback, I think it's also important we listen as to why they're giving a pushback, because that also elicits new information that's useful towards the technology development. With end-of-life care, I didn't get to that topic, but in medical school, there are classes to teach students how to do end-of-life care. And there aren't enough resources for this technique to scale. So they're the one who told me that, hey, if you can provide some kind of automated therapy, automated system for our students to practice in addition to the classroom environment, this will be very helpful.
Good news. Thank you very much.
Another question from Javier.
During the soft skills portion, how is the baseline set? Smiling was.
Yeah, I was just curious on that person. If it's like, you know, I remember you saying that you don't want to change how people speak. You just want to kind of, you know, give some kind of possible improvements in how they, you know, communicate. But is it like a generalized, I guess, suggestions, or is it like based off some kind of like literature? Like how is that based? It's kind of curious.
Right. I mean, some of the recognition algorithms are independent. For example, there are existing algorithms available that can recognize facial expression, like whether you're moving your eyebrow, whether you're smiling. That's pretty standard. So there's computer vision community have already benchmarked it, and computer vision algorithms can do a good job to say whether it's present or absent. So we can use that to show how the graph is changing. But again, at the end, it's not about the absolute value, it's the relative value, right? So how, like if nothing is changing, if you're smiling the entire time, that's problematic. Right. If I'm not changing my volume, that's problematic. So it's really the change that's more important versus the absolute metrics.
Okay. Thank you.
Sure.
So one question I had, Ehsan, was in the beginning, you said like, you know, perhaps it was with Rock Speak, which gives these suggestions to remove some of these sounds in between words. But I feel like that's what makes it more natural in some instances, or makes it more human. If we remove that, maybe it gives a refined tone. I know there are instances where people kind of try to induce these filler sounds sometimes to make artificial agents sound more natural. So what's your thought on that?
Right, so I don't think we remove any fillers. So I'm not sure whether...
Not remove, but the suggestion to kind of, you know, improve on that. Right. But that sometimes is what makes, when you see that vulnerability or some of those things, I think it makes you trust the person more, or there are these other attributes, I think, that are associated with it. So I was just wondering what your thoughts are.
Right. Once again, these are absolute metrics. How you want to engage with them, it's up to you. Usually, public speaking coach will tell you that filler words are not good in a conversation, but you're correct. Sometimes hesitancy is good. I mean, depending on the context. So I know there is technology that's available where I can record my video and I just feed it through it, like Descript technology, and that will just automatically get rid of my filler words. It's like, yeah, applying filter on my speech. And that's what I don't like. I think in our technology, we give an option. Okay, if you want to sound like if everything is removed, this is what you would sound like, but we don't encourage that, right? So at the end, given the feedback, how you want to engage with it is up to you. But I agree with you that we shouldn't fixing the conversation and making it better, just like you would do in a filter on Instagram.
Yeah. Thank you so much for the great presentation and very insightful. And it's great to see how it's actually impacting humans in real life scenarios.
Thank you. You've been a great audience. The audience didn't drop out. The 45 people stayed in, so I appreciate that.
Yeah. Have a great one. Have a great weekend, everyone. See you next week. Bye.
Bye.